Question is about some kind of salt water mixed and leaving the tank. And it gets interesting if you put more than one tank together, because then you're going to have to solve it using system of differential equations. But before we get to the harder systems, I just wanted to show you how you solve this when you just have one tank. So let's think about the following. You have the tank, and there's 100 gallons of water, salt water in there, and 20 gallons per minute of fresh water is coming into the tank, and as it's well mixed, then the mixed salt water, or it's called brine, is leaving the tank also at 20 gallons per minute. And the question is, can you figure out the amount of salt as a function of time? Now, we would actually have some idea of what the solution might look like, because, see, initially it's 12 pounds of salt. And if you have 12 pounds of salt and the mixed salt water is leaving, the amount of salt should be going down, and it's going to get closer and closer to zero. So you would expect that that's the kind of answer you would get, right? But to actually solve this, you need to build a differential equation. And to build a differential equation, you have to use this idea that let's just say x of t is the amount of salt in the tank, then the rate of change of the salt in the tank is equal to the rate in minus rate out. Okay. So it makes sense. If you know how much salt it's taking in, and if you know how much salt it's giving out, then the sum of those two rates, or the difference of those two rates, should give you the rate of change of the salt in the tank. So that's the more generic form that we'll make use of when we have more than one tank, or when we do the two tanks. But in this case, there's no salt coming in because the fresh water is being added, right? So the rate in is 0. And for the rate out, this is how you should think. So let's say you have xt amount of of salt in the tank, xt amount of salt in the tank, and then how much salt would you have inside the 20 gallons of water, the well-mixed brine?
Fifth of the salt?
Would
that be like a fifth of the salt?
It would be the fifth of the salt, right? You would say that because 20 is 1/5 of 100, if xt is the entire salt in the water, then at that point you'll be getting like 1/5 of the x of t leaving the water, right? So the way you think of this as it's 20 out of 100. So you put here the rate out would be, the rate out is, it's xt amount of salt leaving, but not all of them. It's 20 gallons out of 100. And that's how you think of it. And that's kind of easy because now it's a simple differential equation, which is dx dt equals to negative 0.2 x And we've solved many differential equations like this, whose solution is x equals to some constant times e to the negative 0.2t. Right? If you have x prime equals to some constant times k, that some constant k times x, that k goes in here, right? E to the kt. That's the solution. And we can solve this. You can go from here to there either by treating this as a separable differential equation, or you can also think of this as a first order linear differential equation. So either way, you're going to get this solution. And then you just plug in the initial condition, x of 0 is 12, because initially there was 12 pounds of salt. And therefore, you have, when you plug in 0 here and 0 there, you get 12 equals to c times e to the 0th power, giving you c as 12, and then plugging that back in, you get x of t equals to 12 times e to the negative 0.2t. And indeed, our initial idea agrees with the solution. So we know that when you plug in t equals to 0, you'll get 12 as the beginning. And as time proceeds, this becomes e to the negative big number, and e to the negative infinity is 0. So it just goes exponentially towards to 0. So that's what's going to happen. In other words, even after a long, long time, there's still some amount of salt in there, although it's very small.